If I were to say to you, x plus 2 is 4. All right, is that an expression or an equation? And why should I care? Okay, because it's got an equal sign, that means it's an equation, okay? And if I were to say, okay, something plus 2 is 4, you could already do that in your head, right? You could tell me what that number is. Yeah, I see people are already writing in what the answer is. Perfect. Yeah, so that's not a hard one. That's not a hard one. Okay, so x is our unknown, but how do we do it with math when the numbers aren't so nice, aren't so polite like this? We have decimals, we have fractions, we have goofy numbers. Okay, so what we want to do is we want to learn how to get x by itself. X represents what we don't know. This one only has one unknown, okay? And it's the exponent, you don't see it here, but it's just to the first power. We talked about exponents last time. So this is a linear equation. These are nice to deal with. If you graph them, they give you a straight line. Lots of easy things to do. Okay, so here we go. What we're going to do is we're going to get x by itself. So that is the name of the game. Get x by itself. All right, so how do we do that? So that means I'm going to rewrite the equation here. X plus 2 equals 4. All right, so I'm going to take the 2 and I'm going to throw it over there. How do I do that? With equations, anything you do to one side, you've got to do to the other. If anyone's ever been babysitting little kids, you know you can't give one an ice cream cone without the other one being upset, right? So whatever you do to one side, I'm going to say minus 2. Minus 2. Okay. So what does that mean? Plus 2 and minus 2, they cancel. 4 minus 2, that will give me 2. So there's nothing else here besides the x. X equals minus 2. That's it. Okay, let's try another one. We're going to do a lot of these so you get really comfortable. If I said x minus 4 equals 8. All right, name of the game is to get x by itself, okay? So you're going to look and say, what's over here with x? And you say, oh, there's a negative 4. Okay. So if I put a positive 4, that will get rid of that, right? But I have to make sure I also do it over here. You need to do it on both sides of the equation. Both sides of the equation. So that means that this will cancel. That goes to 0. So we have x equals 8 plus 4. We call that 12. Yeah. How does that look so far? We're doing good? Great. Let's do another one. X minus 1 equals 3. Okay. X minus 1 equals 3. Okay. X minus 1 equals 3. So what do you think we should do? What do you think? Any ideas? What do you think we should do? Yes, we absolutely need to do something like that. I agree. Plus 1 is the right thing to do. So this goes to 0. X equals 3 plus 1, which is 4. Excellent. Good, good, good. Okay. So how about we try another one? How about this one? X plus 2 equals 0. Ooh, what if there's a 0 on the other side? How would you handle that? Any ideas? What would you do? How would you handle that? What would you say? I would say minus 2. Minus 2. Now it's not 0. X equals, this goes away, minus 2. Okay, you seen how to start to think about this? Yeah, start to think about this. Okay, let's do another one. Let's do another one. X minus 1 equals, oh, wait, we did that one. I want to do the x minus 2. X minus 2 equals 0. So remember, we're just getting x by itself. X minus 2 equals 0. So we're going to add plus 2 plus 2. So that goes away. X equals 2. Good. Now, I've got people asking good questions. They're asking, where would you get an equation like this anyway? And if you're thinking, yeah, equations don't usually walk down the street like this, you're absolutely right. This is an intermediate step that we're learning. When you get to physics, you're going to learn how to slap one of these down on the paper, and then they're going to assume you already know how to solve it. So we're learning on the, hey, how do you solve it? And then we're going to add the advanced section, which is the application piece, where we're actually going to be doing some chemistry labs and physics labs, and you're going to learn how to put it on paper. Okay, so it's a multi-step process here. So plus 2, x, that goes away. 4 plus 2, we call that 6. All right, so how are you feeling about this so far? Okay, so that, notice on all of the ones that we've been doing, nothing has been in front of the x. So there's like an invisible 1. It's there if you need it, but nothing in, okay, so we just were dealing with what do you do if you have a number. Now let's take a look at what if there was 2x or 4x? What do we do there? Okay, so let's take it step by step. So let's just do this one. So in the last session, we played a game. We said get it to 1, and there was also one of get it to 0. So we were doing different things. Okay, so that's what we're going to use this week. So watch this. So 12 times something is 48. You know your multiplication tables, right? 12 times 4 would give you 48, right? So you already know x is 4. Well, how did you do that? Okay, so what we do is we want to get x by itself. I can't subtract 12. Well, here, if I tried that, watch. 12x minus 12 equals 48 minus 12. So there's no x here, so I can't combine it. So I just made the problem harder. So that's not the solution. So we're not going to add or subtract. Instead, what we're going to do is we're going to divide. So I'll rewrite the problem. 12x equals 48. All right, so I want x by itself. So if I divide by 12, what do I get over here? 12 over 12, the top and bottom, numerator and denominator are the same. So this goes to 1. So that becomes just x. But whatever I do to one side, I have to do to the other. So I divided by 12. I've got to divide by 12. 48 divided by 12. This is 4 times 12. This is 1 times 12. And then the 12 over 12, that goes to 1. So I have 4 over 1, which is known as 4. And that's the answer we saw right off the bat. All right, good, good. All right, let's try another one. What if I said 3 times x equals 12? 3 times x equals 12. Okay. So what do I do there? I'm going to divide by whatever's in front of the x. If there's a 15, I'll divide by that. If there's a million, I'll divide by that. There's only a 3, so I divide by that. And you do it to both sides. Okay. This 3 over 3, that's going to become a 1. Okay. And so I can simply just write down x. You don't have to write 1x because everybody knows that that's what this means. 12 over 3 is also known as 4. Good. All right. So type me a little note. Let me know, how is this feeling so far? How are we feeling so far? So yes. All right. So this is just the beginning steps of algebra. So we are going over how to think about things, how to think about multiplication, division, and how that's different than addition and subtraction, and when to use both of them. And now, so we did just multiplication. We did just multiplication now, and then we did the addition subtraction earlier. Now let's do a problem that has both of them. You ready for that? No? Okay, I'll tell you what, we'll do a couple more multiplication ones, just so you're comfortable, and then we'll start to do ones that have both. Okay, here, how about this one? 5x equals minus 5. Okay, so this is just a multiplication division one. Okay, get x by itself. What are we going to do? Whatever's in front of the x, that's what you divide by. Super easy. Okay, 5 over 5, that gives you 1. And what about this? What's this mess over here? This is 5 over 5 is 1, so that is a negative 1. So what does that mean? That means when you put, so x, here, the original problem was this. Can you see that if I put x is equal to negative 1 in there, 5 times a minus 1, that's going to give you negative 5. So that is what x has to be in order to make this statement true. So that's what we're saying. Great. Okay, good, good, good. All right, so let's try another one. How about this? What if we have a negative, let's see, negative 10x equals 2. What do we do there? Well, we divide by negative 10. So whatever's in front, including the minus sign, and that goes over here. See that? This will go to positive 1, which is what we want. Negative, there's only one of them, so it stays outside, odd number. 2 over 10 reduces to 1/5. So x doesn't have to be an integer. It can be a fraction. Okay? All right, so you're going to divide or multiply to get x by itself. Here's a case where we do the opposite. Watch. What if you have a fraction in front of the x? What do you do then? Same thing. So you can divide both sides by a half, which is the same as multiplying both sides by 2. You see that? 2 times a half, that will make the half go away. So only be left with, because if you have 2 halves, you have a whole, right? 2 over 2 is just 1. So that's x minus 2 times 2, 4. Okay, you want to do another fraction one? Okay. Yeah, so what did we do? We divided by whatever's in front of the x. We divided by a half, which is also the same as multiplying by 2. And we're just getting the x by itself. That's all we want to do. Get the x by itself. Need some alone time. Yep. Okay. What if we have a 3 halves x equals 3? What do we do there? Get the x by itself. You're going to multiply it by whatever you need to get that thing to equal 1. But whatever you do here, you must do here. Okay? Even if it makes a yucky number, still got to do it. So this, I just multiplied by the reciprocal, so I made the fraction do a handstand. 2 over 2 gives you 1, 3 over 3 gives you 1. I'm left with x on this side, so that cancels completely, equals, the 3's will give you cancel, combine to give 1. I am left with x must be 2. Okay. And we can see that that's true, because if we take the original problem, 3 halves times x equals 3. The only value of x that'll make that true is if you put a 2 in here. The 2's cancel, you have 3 equals 3. Good. All right, so how are you feeling about this so far? Good? Okay, let's take a quick little break. I've got my water. Okay, look over a couple of questions here, see how we're doing. All right, so if the video is freezing, I am so sorry about that, but I will make sure that you have a good recording. I will make sure you have a really good recording. Okay, so it looks like we are having trouble with stream again. Okay, so let me fix this. Okay, is that better? I hope that's a little better. Okay, all right, so now we're going to go ahead and continue. So now we're going to do the multiplication division part. We're going to do that with addition subtraction. So we're going to make it as complicated as it can go. I remember in math class always being frustrated that the teacher did all the easy ones and then they'd give you ones that you know they did not cover in class. So I want to make sure I do some really hard ones so you can see how that goes. Okay, so let's go back down to my desk. Okay, so I have a 6x plus 6x equals 12. Here, plus 12. There we go. All right, so the first thing I want you to do is combine terms that are the same. Yeah, we practiced this last week. Which ones are the same? These are the same. 6 plus 6 is 12. X equals 12 plus 12. There's no x's on either one, so that is the same. Now, we just did problems like this. So we want the x by itself, divide by whatever's in front of the x, minus signs included. Okay, 12 over 12 gives you 1. X is, 12 goes into 24 2 times. Okay, the first thing we did is we combine like terms. We did this quite a bit last week. Like means the same. Not like I like chocolate, different kind of like, okay? And then we get x by itself. That is the name of the game. So combine like terms, then get x by itself. Okay, good. All right, let's try another one. Okay, I have a x plus x plus x equals 18 plus 6. What do you think about that one? Yep. So we're going to combine those. 1, 2, 3 equals, and what do you think about that? 18 plus 6, that's going to be, how much is that going to be? 24? Divide by whatever's in front of the x. That will go to 1. X is equal to 8. Good. So we combine like terms. We get x by itself. And then we solve. Yeah, it's very methodical once you get into it. Okay, good. Should we try another one? Let's try another one. So I have minus 12x plus 18x minus 3x equals 6. Oh my. Okay. So minus 12 plus 18. This is going to give me a 6x minus 3x equals 6. So it's okay to do it in steps. 6 minus 3 is 3x equals 6. Okay. Divide by whatever's in front of the x. This goes to 1. 3 goes into 2. Oh, I'm sorry, 3 goes into 6 2 times. So this 6 over 3 reduces to 2. Good. All right, I have another one. You ready for another one? How about this one? I have 5x minus 17 equals 3. Ooh, this one's different, isn't it? So we have numbers without x on both sides. So I like to put these on the left and these on the right, but you do what you are comfortable with. But if I have a standard procedure, then I don't have to reinvent it every single time. I can get the same answer each time. So you do the addition first or subtraction first. Get the numbers, don't divide by 5 because it's too hard. 17 over 5 is a yucky number. So get this over there. 17, so that goes to 0. This becomes 20. I have 5x equals 20. Do you see how this is easier now? So divide by 5, and the x becomes, this turns into 1, this turns into a 4. Okay, so what did I do there? So the first thing is I'm going to combine like terms. Again, like is just a name for similar terms. Okay, similar means these don't have an exponent, or these don't have an x, and this one does. Okay, so the ones that have an x associated with it, you want it by itself on one side of the equation, and all the ones with no x on the other side. Then it makes it easy to isolate it. Otherwise, you can still do it, but you'll have, if you divided this by 5, you would have x minus 17 fifths plus 3 fifths. And that's just messy to deal with. Yeah. Okay, so once we have that, then we want to get x by itself. Okay. All right, you ready to do another one? Okay. Minus 14 equals 9x minus 5. Okay, you start this one. You start it. Okay. Go ahead and do the first one. Okay. What do you need to do first? What do you need to do first? Okay, that's right. You're going to combine. You're going to combine like terms. So what are those like terms? Okay. Did you do this? I know. Just when I said put one on the left and one on the right, we get one where they're flipped. Okay. So here's, I'm just going to get x. I'm just going to throw this on the other side. So this becomes a 0. This becomes a minus 9 equals 9x. Okay. I'm going to divide by whatever's in front of the x. So that goes away. X equals 9 over 9 is 1, so that's a minus 1. Okay. All right. And somebody's asking what workbook we're on. I actually haven't told you that yet. We're just having some fun learning some new skills. Okay. So let's do, you guys want to do a couple more? Let's do some more. I'm going to do a 4. I'm doing, I think I can get that in there. 4 minus 10x equals minus 16. Okay, so how do we do this one? Okay, we're going to combine like terms. So I'm going to say minus 4, minus 4. So that's going to go away. I have a minus 10x equals minus 20. So whatever's in front of this, which is minus 10, whatever's in front of the x, I'm going to divide it out. Okay. include the negative sign. Include the negative sign. Because remember, I want a positive x, positive 1x. Two negative signs are, that's even. There's 2 is an even number, so that becomes a positive. And 20 over 10. 10 goes into 22 times. If I tell you this one, minus 140 equals minus 10x, what would you do? This is really similar to the one we just did. Yep, you divide. There's no terms, no like terms, so you skip that step. You're going to divide by minus 10, divide by minus 10. So we're not dividing by the x because we want x. We are only getting rid of whatever's in front of it. And we can't subtract it because it's stuck here with a multiplication symbol. So that gives us x equals, there's 2 negatives, so that's a positive. 10 goes into 140, so the zeros cancel, and you have 14. Okay. All right, so drop me a little note and let me know how we're doing. How are you feeling about it? All right, well, thank you guys so much for being with me. If you have a question that didn't get answered, let me know over at superchargedscience.com. And I look forward to seeing you in our next class. Bye-bye, everybody.